Hey geometry, let's talk about lines that pass through regions. So last lesson we talked about rectangles and triangles making regions, and now just plain old lines that are passing through regions. So as an opener, how can we use the Pythagorean theorem to find the length AB? Let's label this A and B, right? In other words, the distance between A and B. Find the distance between A and B. I can draw a triangle here and count 1, 2, 3, 4, 5, 1, 2, and use Pythagorean theorem. We have 25 plus 4 is 29. So AB equals the square root of 29, which I can't do anything with, right? But what I really want to show you with this example is how we're using Pythagorean theorem, which will get us the distance of, or the length of AB, how using Pythagorean theorem proves the distance formula, which we are going to learn. So if we see here, I've got this distance right here. Let's see, this is A, because it's the x value, this is C. So if we do, C minus A gives us this length right here. C minus A, positives and negatives don't matter. C minus A plus, if we look at the y values, this is B and D. D minus B squared, that gives us the length of segment AB. So review, we did C minus A, quantity squared, and D minus B, quantity squared. So I used this one first and I went over here. So C minus A, which are the x values, and D minus B, which are the y values. So if I solve for this, AB would be equal to the square root of C minus A, quantity squared, plus D minus B, quantity squared. This right here is called the distance formula. Cool? Awesome. So look at this region. It says consider this region. We're going to use this example in the next few questions. I just wanted to show it to you a little bit bigger first. All the red lines are single unit digits. Let's see. I don't like how they did that red and blue, so let's look at it. Here I've got over 1 up 2. So every square is a unit, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yep, 1, 2, 3, 4, 5, 6, 7. So it's true. We've got a rectangle here. I think it's the same rectangle we used in lesson 2. So let's use that rectangle and answer some questions. First of all, does a line of slope 2 passing through the origin intersect this rectangular region? Let's look at it. If so, which boundary points of the rectangle does it intersect? Explain how you know. So let's just start at our origin and count a slope of 2, which is rise over run. Oh, for goodness sakes. M equals 2, which is 2 over 1. That's your rise over your run. So we have 2 over 1, so 1, 2, 1. 1, 2, 1, 1, 2, 1, 1, 2, 1. That gives me that straight line. So it does pass through. I had to reread the question. So yes, it does pass through. If so, which boundary points of the rectangle does it intersect? Right there, 1, 2 is the boundary point that it intersects. And then right up here, it intersects at 3 1/2, 7. How do you know? Well, I drew it. I do know this is an equation. My y-intercept is 0. My slope is 2, so I can write the equation y equals 2x. I could set up a table where x equals 1, I plug that in, y equals 2. That's on my line. And then I need one where, what is x when y equals 7, to find my other point up there. So I would plug that in. Nope. 2x equals 7, divide both sides by 2. I know that x equals 3.5. So my equation is the most useful thing to answer that question. Now let's try the next one. Does a slope of 1/2 passing through the origin intersect this rectangular region? If so, which boundary points of the rectangle does it intersect? So I've got 1/2, up 1/2, up 1/2, up 1/2. I'm still going. So there's my line. What's my equation of this line? This line is y equals 1/2 x. It definitely intersects right here, which is over 1, 2, 3, 4, up 2, 4, 2. I can plug that into the equation to make sure. So we have 2 equals 1/2 times 4. Yep, we're good. Then the point up here is over 14 up 7, which also works in the equation. 14 equals 1/2 times that. 7 equals 1/2 times 14. It works. Does a line of slope 1/3, so I'm doing a rise of 1/3. 1, 1, 2, 1, 2, 3, 1, oh. 1, 1, 2, 3, 1, 1, 2, 3, 1, 1, 2, 3, up 1, 1, 2, 3. My equation is y equals 1/3 x. My first point is over 1, 2, 3, 4, 5, 6, 1, 2. And my last point is over 15 up 2, 4, 5. Which also works in the equation. Plug it in and double check that they're valid answers. Okay, part D. A line passes through the origin at the lower right line and the lower right vertex of the rectangle. Does the line pass through the interior of the rectangular region or the boundary of the rectangular region? Does the line pass through both? So it goes through the origin and the lower right. Does the line pass through the interior of the rectangle? Well, what do you guys think? I'm going to have to say nope. Does it pass through the boundary of the rectangular region? Yep. It passes through right there, right on the corner. Does it pass through both? No. So look at it. I mean, it hits the corner, so it does hit the boundary, just not the interior, right? All right, let's work through part E. For which value of m would a line of slope m pass through the origin and intersect this region? Well, let's just look. If I pass through the origin, that would be my largest slope, right? Let's draw a little line through there. Oh, what's my slope of that line? So rise of 1, 2, 3, 4, 5, 6, 7, run of 1. So m equals 7 over 1. And let's do the furthest away. So it'd have to pass through here and there. This is a slope of rise of 2, run of 15. Rise of 2, run of 15. So any m value in between there would be a valid answer, right? So I could use, say, an inequality. Let's see. 2 over 15 greater than or equal to m less than or equal to 7 would work. It would actually be impossible to list each value of m because they're not asking for integers, they're asking for values, so it could be anything. So I mean, I could draw points at all these and get values of m. You know, any slope. You know, that one's going to be rise of 7, run of 2, rise of 7, this would be 7 over 2, rise of 7, run of 3, rise of 7, run of 4, etc. So really, we're going for any values of m between 2/15 and 7, anywhere in between. All right, for which values of m would a line of slope m pass through the point 0, 1 and intersect the region? Let's put that point up there. I've got 0, 1. And I need a line to go through this point at numerous slopes. What would those slopes be? So again, I can have from there all the way over to here. So the slope of the line going through there to there. So what's the slope of this first line? I've got a rise of 6, a run of 2. 1, 2, 3, 4, 5, 6, a run of 1. So 6 over 1 is my slope, and this one would be a rise of 1, a run of 15. Rise of 1, a run of 15. So my answer would be another range. My smallest number would be 1 over 15. And my largest slope would be 6. So between 1/15 and 6. So really I just translated my graph, right? I shifted it. The graph moved up by 1 unit. That's all right. All right, let's step it up a little bit and get some harder problems. All right, so let's read. Consider the triangular region in the plane given by the triangle with vertices shown. The horizontal line, y equals 2, intersects this region. What are the coordinates of the 2 boundary points it intersects? What is the length of the horizontal segment within the region along this line? So let's do the 2 boundary points first. This one right here, easy. I can read it from the graph, and I know it intersects right at that point C. So the first one is going to be 4, 2. This one back here, can't read so much, so I'm going to have to do some algebra. I do know that the intersection of 2 line segments, I can find it by solving a system of equations. If you guys remember solving a system of equations in algebra. So I need the equation for segment AB. I have to come up with the equation. I know its y-intercept is 0, and the slope is a rise of 3, a run of 1. So my equation is y equals 3x plus 0. So my system of equations is y equals 2 and y equals 3x. I'm going to set those equal to each other and solve for x. 2 equals 3x. Divide both sides by 3. X equals 2/3. To find the y value that's associated with that, I need to plug it back into an equation. Three times 2/3. Those cancel out, therefore y equals 2. The ordered pair is 2/3, comma 2. So I've got this point right here and this point right here. Now the length of the horizontal segment, that's our distance formula. So I need to find the distance between these 2 points, and I need a new slide. So the distance between 4, 2 and 2/3, 2. If you remember, the distance is equal to We're going to say x2 minus x1. I know we used letters earlier. Squared plus y2 minus y1 squared. So I can pick anything, x1, x2, it doesn't matter. I just need my x1 and my y1 to be together and my x2 and my y2 to be together. x2 minus x1, 2/3 minus 4 squared plus y2 minus y1, 2 minus 2 squared. And that makes sense because it's a horizontal line. 2/3 minus 4 is 3 1/3. I don't like squaring that though, so I'm going to put it into improper fraction. 10/3. Oh, but it doesn't matter because I'm squaring a square root. That is my distance, units. 3 1/3 makes better sense to me than 10/3. So I had my distance formula to get that. Awesome, let's move on. Graph the line 3x minus 2y equals 5. Find the points of intersection with the boundary of the triangular region and label them as x and y. I can't graph this. I need to put that in y equals mx plus b form. So I'm going to move the 3x to the right and divide everything by -2. That's wrong. 3 halves x plus 5 halves. Okay, 5 halves is the same as 2.5. So move down 2.5. Let's see if I can clean that up. Oh, goodness. And go a rise of 3, a run of 2. So 1, 2, 3, 1, 2. If you see, I just did 1, 2, 3, 1, 2. And then 1, 2, 3, 1, 2. And now I'm through the graph, but let's see if I can do any more. Nope. 1, 2, 3, 1, 2. Okay, draw a line. So we're trying to find point x and point y. And it doesn't end up in a pretty little point, so I have to do some hard work and solve a system of equations twice. So I know that this is one of the equations I'm going to use to solve my systems of equations. I need to figure out what the what the equation for segment AC is. Segment AC has an equation. I know my b, my y-intercept, is 0, and my slope is, let's see, a rise of 1, a run of 2, 1/2. So my equation is y equals 1/2 x plus b, which is 0. And then let's look at BC. I may not have room to do the work on this slide, but it's all right. I don't have a y-intercept. I know my slope is a rise of 2, a run of -1. Let's see if I can figure out my b easily. 2, 1, 2, 1, up 2 over 1. I'm up there. That's at 1, 2, 3, 4, 5, 6, 7, 8. And I need a rise of 2 and a -1, so that's going to be up at 10. So here I'm going to go up 2 and over 1, which I'll be up at 10. Cool, I figured it out. So the equation here is y equals -2x plus 10. So I have two systems of equations. I'm going to work with single star and double star. Then I'm going to come back and work with single star and triple star. I need to know where those two systems of equations intersect, and that will give me my answer. So segment AC and my equation intersect here at x. That's the system over here. Then segment BC and my equation intersect here at y, and that'll be my system down here. So let's do some math. I'm going to solve the systems of equations by setting the equations equal to each other. The first thing I'm going to do is multiply the entire equation by 2 to get rid of all those 2's at the bottom. So I'll end up with x equals 3x plus 5, negative 2x equals 5, x equals negative 5 halves. Okay, got x. What's y? Plug it back into one of the equations. Negative 5 halves. I don't think that negative is right. What did I do wrong? Oh, I got this wrong at the beginning. This should be a negative 5. Nope, not there. This should be a negative 5 because I divided by a negative 2. I had positive 5 divided by negative 2. So that's a negative, negative. That's going to be a positive. Cool. I knew it was wrong because that should be a negative. Because of what quadrant I'm in. I'm up here. Everything's positive up here. I shouldn't have a negative value. So I was just aware of what was going on. Multiply across, I get 5/4. So my first order pair is 5 halves, comma, 5/4. This is x. Okay, new slide for y. Okay, here were the other 2 systems of equations. I have segment BC and the equation that was given to us, the line that was given to us that's cutting through. I'm trying to find y right now. So let's set these equal to each other. 3 halves x minus 5 halves. And again, I'm going to go ahead and multiply the whole thing by 2, just because I don't like fractions as much as you don't like fractions, right? Negative 4x plus 20 equals 3x minus 5. I distributed a 2 through the whole thing. So now let's go ahead and solve for x. Negative 7x minus 20 is negative 25. Yuck. X equals 25 over 7. Let's plug it back into an equation. There's no pretty equation to plug this into. Goodness, this sort of stinks. Really, when I get a messy equation like this, I think to myself, what mistake did I make? There's no good equation to plug it into, so just pick one. Negative 2 times 25 over 7, just carry over, it's like multiply straight across the numerator and the denominator. Negative 50 over 7 plus 10, which would be 70 over 7. Yeah. And that gives us 20 over 7. So my ordered pair here is 25 over 7 and 20 over 7. That is the y on the graph. Oh, that was hard. Good job. I'm happy they didn't give us like a super easy as pie problem and then put a super duper hard one on the problem set. Now we need the length of xy. Let's see, let me write down the values of xy. I need to look back, there we go. 5 halves, comma, 5/4, and 25 over 7, comma, 20 over 7. So the length is our distance formula. Distance equals, subtract the x's, 5 halves minus 25 over 7 squared plus, subtract the y's in the same order. 5/4 minus 20 over 7 and square them. I'm going to use my handy dandy calculator though, so hold on, I'll be right back. Alright, that's what I got. Approximately 1.96 units. Phew. Alright, a robot starts at position 1, 3, over 1, up 3, 1, 2, 3, and moves vertically downward towards the x-axis at a constant speed of 0.2 units per second. Straight down. When will it hit the lower boundary of the triangular region that falls in its vertical path? So I'm going to erase that so I can see it. So really we're trying to get from here to there. I just took a second and found the ordered pair at the second dot. I wanted to know what that location was. So I know I needed to solve a systems of equations, x equals 1 and y equals 1/2 x. So that is segment AC. So I need to find the ordered pair where those two intersect. The system of equations. Solve the system. So I plugged 1 in for x. I substituted and solved for y. And I got 1/2. So the ordered pair at this point over here is 1, 1/2. So I need to know the traveling from 1, 3 to 1, 1/2. I'm traveling in a vertical direction. So really, what is, excuse me, what is this distance? I can use the distance formula, or I can just see that I'm going 1, 2.5 units. At 0.2 units per second. So 2.5 units divide by 0.2 units per second equals 2.5 divided by 0.2, 12.5 seconds. That was sort of fun. Oh, forgot a D. Alright, let's try another one. Consider the given rectangular region. Draw lines that pass through the origin and through each of the vertices of the rectangular region. Do each of the 4 lines cross multiple points in the region? Explain. Let's see, I'll use red. I wish I had a ruler. Through the origin. Do each of the 4 lines cross multiple points in the region? No, not all of them. Let's see. Get a pen back out. Only the lines that pass A and B pass through multiple points in the region. Alright, we already answered part A. Write the equation of a line that does not intersect the rectangular region at all. We could all write equations of different lines. I'm going to write this one. That is a line y equals, I don't know, that could be 7. X equals -2. Be down, oh no. Would be over here somewhere, etc. We can all do that, right? And final slide. A robot is positioned at D and begins to move in a straight line with slope m equals 1. So we're at D doing slope equals 1. When it intersects with a boundary, it then reorients itself and begins to move in a straight line with a slope of m equals -1/2. What is the location of the next intersection the robot makes with the boundary of the rectangular region? So we need to figure out where it crosses using a slope of 1. But let's get rid of that. If we're starting out at -1, 1, we're going to go up 1 over 1. So we're at the y-axis at this point. And my red point is going to be, let's see, x is 0, y is 2, because we just went up 1 over 1. So my equation of a line is going to be y equals m x plus b. The y-intercept is always at the y value where x equals 0. So I'm going to see where this intersects. I could count my slope out, but I'm going to solve it with the system of equations at y equals 4. So 4 equals x plus 2, x equals 2. Plug that back in to any equation. Y equals, I'm going to plug it back into that equation, 2, 1 times 2 plus 2. Y equals 4. So my ordered pair is 2, 4. So that is up here. So that right there is at a slope of m equals 1. And we have our equation right here, m equals 1. So once it hits that boundary, it turns and it begins to move in a straight line with a slope of m equals -1/2. So let's find out where we go. So I'm starting here, and I'm going to go down 1 and over 2. Well, I'm at 2, 4. So if I go down 1, that's going to be -1. Let's see, I'm starting out at 2, 4 with a slope of -1/2. So my rise is going to be down 1, so my y value will change by -1. And my run, so I'm going down 1 and over 2, my run will be +2, which will be a 4. So my ordered pair is 4, 3. Cool. What is the approximate distance of the robot's path in part C? So I'm starting with, this is where the robot started and ended the first time. And then the robot started there and ended there. So I'm really doing two distance formulas. Distance equals the square root. I'll do x minus x squared plus y minus y. And then add that to x minus x squared plus y minus y. Let's see. 2 plus 1 is 3 squared is 9. 4 minus 1 is 3 squared is 9. 9 plus 9 is 18. I made that really long for some reason. Plus 4 minus 2 is 2 squared. Plus 3 minus 4 is -1 squared. So 4 plus 1. 4 plus 1 is 5. Oops. So crunch the numbers. Square root of 18 plus the square root of 5 is 6.47. We'll say about 6.5 is the distance of that. All right, that's the end. This stuff is a little tough today, so we may need some extra help tomorrow in class. But just know that you can work through it and understand it, and we'll get there. Awesome. Good job.